Hello students, today we will discuss about unit, dimension and measurement. That is the first unit of your class 11 syllabus and as well as your NEET and JEE. First of all, we should know what is the physics. Actually, physics deals with nature. Physics deals with nature. Now, what is the component of your nature? There is a 4 component in your nature. What are this nature means? Nature, there is plant, there is plants, there is animal, there is matter and also energy, this is the 4 component of your nature. This is the 4 component of your nature. If you want to know plants and animals, you have to go biology. If the study about plant and animal is called biology, but here study about matter and energy is called physical science. This subject is combination of 2 subjects, that is physics and chemistry. That means physics and chemistry, both subjects deals with matter and energy. But there is a difference, basic difference. What is the basic difference? This physics deals with matter and energy in broad aspect. But chemistry deals with matter and energy in a molecular and reaction basis aspect. This is the basic difference of physics and chemistry. Now, you think that there is a vast number of quantity related to our daily life. That means length is a one quantity, speed is a quantity, energy is a quantity. That means length is one type of quantity, mass is a quantity, weight is a quantity, speed also a quantity, velocity also a quantity, force also a quantity, and energy also a quantity. Like this, there is a vast number of quantities, and also sadness and sorrow. That means happiness also a quantity, sadness also a quantity, sorrow also a quantity. But there is a difference. You know that length can be measured, mass can be measured, weight can be measured, speed also can be measured, velocity also can be measured, force can be measured, energy can be measured. That means this quantity can be measured. But you cannot measure happiness. There is no unit. What is the amount of happiness? What is the amount of sadness? What is the amount of sorrow? This quantity cannot be measured. Cannot be measured. So the measurable quantities is called measurable quantity is called physical quantities. But this quantity is not a physical quantity because it cannot be measured. That's why it is not a physical quantity. Now, physics physics deals with physical quantities. That means physics described describe about physical quantities, but and also it describe the laws of nature. Actually, nature gives the phenomena and physics solve it. There is the number of phenomena related to nature, and physics solved these phenomena with the help of various number of laws. So in your physics book there is a description about physical quantities, that means measurable quantities, but there is no description about happiness, sadness, sorrow, because physics cannot describe a non-measurable quantities. Is a non-measurable quantities. This is the then you have to know what is physical quantities. You know it. Now, apart from physical quantities, you know that what is physical quantities? Mass is a physical quantities. You know that mass is a physical quantities. Now, if you want to buy rice, and you have to go market, then say that give me two rice. Give me two rice. But is a meaningless. Because this is meaningless. But if you say that 2 kg rice or 2000 gram rice is a meaningful. If you want to buy a wire, you have to say 2 meters wire, or 200 semi wire. This is meaningful, but this is not meaningful. It is a meaningless. You say that 2 wire is a meaningless. So if you describe a physical quantity, if you want to describe a physical quantities, you need two things. One is magnitude. This is a magnitude, and this is a unit. So to describe a physical quantity, you need two things. One is magnitude, and another is unit. So any physical quantities can be expressed as magnitude and unit. This is a magnitude, and this is a unit. Here, this is a SI unit. This is a SI unit system. This is a CGS unit system. Here, this is a greater. This unit kg is greater than gram. So the value of n, this one. So say that n1 u1 equals to n2 u2. This is a SI system. This is a CGS system. If you then kg greater than gram, that means u1 greater than u2, then n1 less than n2. Look at this. This is 2 kg. This value is less, but it is a 2000 gram. 2 kg means equals to 2000 gram. For a specific amount of mass, if you take greater unit compared to the other, then the magnitude will be less. That means u and n are inversely proportional to each other. That means if you take a greater unit, then the magnitude of the same quantity will be decrease. So unit and magnitude is indirectly inversely proportional to each other. That is the physical quantities. You know that what is the physical quantities and what is the properties of physical quantities. Now I will describe about types of physical quantities. There is 3 types of physical quantities. There is a 3 types of physical quantities. One is scalar quantities. Another is vector quantities, and another is ratio of two similar quantities. Now you have to know that what is scalar quantities, what is vector quantities, and what is the ratio of the two similar quantities. You know that mass, energy, work done, speed. Now if you take force, weight, velocity, and acceleration. This is a physical quantity. Also this is a physical quantity, but there is a difference. If you take mass, there is nothing. If you take mass, this mass only have magnitude. There is not a specific direction. Mass have only magnitude, but they have no specific direction. Also energy, only magnitude, no need to specific direction. But work done also have magnitude, but no need to express the direction. Speed also. But so this quantity have only magnitude but no specific direction, only have magnitude. That means magnitude have magnitude but have magnitude but no specific direction. Here these quantities have magnitude and also a specific direction, both. It has both magnitude and direction. That means scalar quantity have only magnitude, there is no specific direction, and vector quantities also has both magnitude and specific direction. Now if you want to add two scalar quantity, that means 2 kg plus 2 kg, also implies to 4 kg, but here 2 Newton plus 2 Newton not is equal to 4 Newton. That's why the addition of scalar quantities obeys the laws of algebraic rule, but vector quantities does not. Addition and subtraction of two vector quantities does not obey the algebraic law. That means addition and subtraction of two scalar quantities obey the laws of algebraic laws, obey algebraic laws, but vector quantities does not obey the algebraic laws. It obeys the triangle and parallelogram laws of vector addition and subtraction. That means scalar quantities, addition of two scalar quantities obey the algebraic laws of addition and subtraction, but vector quantities does not obey the algebraic laws. This is not applying. This is a condition. If 2 Newton equals to 2 Newton equals to 4 Newton when two force in the same direction, but there is another direction, so it 2 Newtons plus 2 Newtons always does not imply to 4 Newtons. Another difference is the product of two vector quantities and product of two scalar quantities. Product of two vector scalar quantities always be a scalar quantity, but product of vector quantity may be a vector or scalar. This is the main difference of scalar and vector. And ratio of same quantity, that means there is a refractive index is a ratio of two similar quantities. That means velocity of light at vacuum and velocity of light at medium. That means the ratio of two velocity is equals to refractive index. This is the three types of physical quantities. Now there is some quantities which have no specific have specific direction but does not obey the laws of triangle laws of vector addition, parallelogram laws of vector addition. That means trace is a one types of quantities. It has magnitude and direction is considered. So but these quantities does not obey the laws of triangle and parallelogram of vector addition. So this quantity is not a vector quantity. This quantity is called tensor. Current has a direction, but it does not obey the laws of triangle and parallelogram laws of vector addition. That's why it is not a vector quantity. Now I have completed the types of physical quantities. Now, apart from various physical quantities, there are some quantities which is independent to each other. Say mass, length, time, velocity, acceleration, force, pressure, work done. You see that mass, length and time is independent. Mass, length and time is independent to each other, but here velocity is displacement by time. Displacement means one types of length and time means this time. That means velocity is depend on length and time. And acceleration means velocity divided by time. It depends on time and velocity, that means length. Force also mass into acceleration, that means force is depend on time and length. Pressure also force upon area. It also depend on time, area, length, mass. And work done equals to force into displacement. So this quantity is independent to each other, does not depend to other quantities. So this is called a fundamental quantities. And this called a derived quantity. So what is fundamental quantities? fundamental quantity is independent to each other, or derived quantity is derived from fundamental quantities. What is derived quantities? The quantity which is derived from fundamental quantities. There are 7 fundamental quantities. 7 fundamental quantities. That means mass, length, time, temperature, intensity, current, and amount of substance, that means matter. Substance, that means matter. One, two, three, 4, 5, 6, 7. There are 2 additional fundamental quantities, that means plane angle and solid angle. That is a plane angle and solid angle. This is the 9 fundamental quantities in your syllabus. This mass, length and time, these 3 quantities is very important to your class 11 syllabus and related to mechanics. Mass is denoted by M. Mass unit kg is denoted kg. Length SI unit meter. Time second. Temperature Kelvin. Intensity candela. Current ampere. And amount of mole. And plane angle has radian, and solid angle is steradian. So mass is a unit of mass is kg, length is meter, and time is second, and temperature quantities. Now we have to know that what is the unit of fundamental unit, what is derived unit. The unit of fundamental quantities is called fundamental unit, and the unit of derived quantities is called derived unit. Here the unit of mass is kg, length is meter, and unit of time is second. So what is fundamental unit? The unit of fundamental quantities is called fundamental unit. That is, unit of mass is kg, unit of length is meter, and unit of time is second, unit of temperature is Kelvin, the unit of current is ampere, unit of amount of substance or matter is called mole, and unit of intensity is candela. This unit, plane angle and solid angle, is very important to your syllabus because it is unknown. So plane angle, unit of plane angle is radian, and unit of solid angle is steradian. So you can easily determine the unit of derived quantities. How? The velocity means velocity. What is the unit of velocity? It will be, velocity means displacement by time. So displacement, unit of displacement is meter, and unit of time is second. That means meter inverse second. What is the unit of acceleration? Acceleration will be velocity by time. The unit of velocity is meter inverse. Here is second. So meter in second inverse 2. What is the unit of force? Force will be mass into acceleration. Here is meter. So kg meter second inverse. How it can? Because force equal to mass into acceleration. The unit of acceleration meter second inverse 2. Here unit of mass is kg. So unit of force is equal to kg meter inverse 2. What is the work done? Work done means force into displacement. Force means Newton into meter. This is the work done. What is the pressure? Pressure is Newton per meter square. That means Newton per meter square, that means Pascal. In this way, you can easily determine the unit of derived quantities. Now we have to discuss that what is the dimension of a physical quantity. What is the dimension of physical quantities? What is the dimension of physical quantities? Dimension of physical quantities. Here, this is the 9 fundamental quantities. So, dimension is nothing but a symbol of the physical quantities. How? Here you see that the mass is denoted by m. What is the dimension of mass? That means m. M is the dimension of mass. What is the dimension of length? Length is denoted by capital N. What is the dimension of length? Is m. What is the dimension of time? Is t. This is the fundamental. These three is fundamental quantities, and dimension is independent of each other. M, L, T. But when you calculate the dimension of derived quantities with the help of these three, that means what will be the dimension of velocity? Velocity dimension means displacement by time, then it will be L t to the power t, L t to the power minus 1. That means dimension of velocity is L t to the power minus 1. What is the dimension of acceleration? You can easily calculate. Here, acceleration means velocity, change in velocity divided by time. Then time. Here, velocity is L t to the power minus 1. L t to the power minus 1, and here t, that means L t to the power minus 2. What is the dimension of force? Force means mass into acceleration, that means mass is m, acceleration is t, L to the power minus 2. It is the dimension of force. What will be the dimension of work done? Work done means force into acceleration, force into displacement. That means force is m, L t to the power minus 2, and displacement is s, L. That means m, L square t to the power minus 2. What is the dimension of pressure? Pressure is force divided by area. Force by area. Here is force is m, L t to the power minus 2, and area is L square. That's why it will be L minus 1 and t to the power minus 2. In this way, you can calculate the dimension of any derived quantities. That means dimension is nothing but a symbol of a physical quantities which is expressed in terms of mass, length, and time. This is the exponential form of m, L, and t. So, if you want to know what is the dimensional equation, then the dimensional equation is written as suppose force is dimensional is m, L t to the power minus 2. So this is the dimensional equation. This is called dimensional equation. It's called dimensional equation. Now, what is the application of dimensional analysis? Here, there is a many function of dimensional equation. One is to calculate the unit of a physical quantities. Physical quantity. You can find out the unit of a physical quantity with the help of dimensional equation. So suppose here force. What is the unit? What will be the unit of force? Here, with the help of dimensional equation, you can easily calculate the unit of force. Here, the dimensional equation of force is m l t to the power minus 2. Here, the unit of mass is kg, unit of length is meter, and unit of time is second. That means the unit of force will be kg meter second inverse 2. What will be the unit of work done? The equation work done, the dimensional equation work done is m l square t to minus 2. Then it will be kg meter square second inverse 2. In this way, you can calculate any unit of a physical quantities. This is the one application of a dimensional equation. To find out the unit of a constant. That means suppose the F equals to G m1 m2 by r square. It is the gravitational constant. This is called gravitational constant. Gravitational constant. With the help of dimensional equation, you can easily find out the unit of gravitational constant. So G is F into r square divided by m1 m2. Here, what is the dimension of F? F is m l t to the power minus 2. What is the dimension of r? That means distance. That means l square. What is the dimension of m? Is m. What is the here is m? That means it will be this m. This means can cancel out. That will be m inverse 1 l inverse l to the power 3 and t to the power minus 2. That means the unit of G is kg inverse 1 meter cube second inverse 2. In this way, you can calculate easily the unit of a constant. This is the two application of a dimensional equation. Then 3. You can convert the unit of a physical quantity from one system to another system. That means you can convert the unit from one system to another system. Suppose any physical quantities, the dimension is m to the power a, l to the power b, and t to the power c. This is the any physical quantity. Suppose a physical quantity, A is a physical quantity whose dimension is m to the power a, l to the power b, and t to the power c. This is the dimension of any physical quantities. So suppose this is the first unit system, there will be m1 L1 and T1. In another is second unit system, unit system, that will be M2, L2, T2, that will be A, eta B and C. The magnitude of the value is N1, here is N2. This will be equals, only difference is magnitude and unit of mass, unit of length and unit of time. This equation must be equal. Suppose 2 kg equals to 2000 gram. The unit is different, value is different. In this way you can think that so you can calculate what will be the N2. N2 will be M1 by M2 whole to the power A, L1 by L2 whole to the power B, and T1 by T2 whole to the power C. What is M1? M1 is the mass of unit of mass in first unit system. L1 is the unit of length in first unit system, and T1 is the unit of time in first unit system. This is the equation. With the help of this equation, you can easily transfer from one system to another system. Suppose 2 Newton is equal to 20 newtons equals to what dyne? You have to, using this equation you can easily calculate. Then N2 equals to N1. Here is N1. Must be, here is N1. Here N1 is 20, and unit of SI system is mass kg, and here is gram, and F is dimensional equation. F is m n t to the power minus 2. That means here m to the power 1, and L means 1 meter and 1 semi. Here is 1, and here 1 second and 1 second. Here is minus 2. So what will be the value of N2? N2 means 0.20 into 1 kg means 10 to the power 3 gram and is 1 gram. Here 1 meter means 10 to the power 2 semi divided by 1 semi, and here 1 second is 1 second, 10 to the power minus 2. So it will be 20 into, here is gram cancel out, semi cancel out, and second cancel out. That means it will be 3 and 2, 10 to the power 5. 3 and 2, it will be 10 to the power minus 3, minus 5 is equal to dyne. So you can easily calculate or convert the system, unit system. Here is SI system, 120 Newton equals to 20 into 10 to the power 5 dyne. In this way you can convert the value of one system to another system. This is the application of dimensional analysis. In the next lecture, we will discuss what is the problem related to the